even more extreme, right? So a lot of times it looks even flatter in there than I've drawn it, okay? So that's the cubic function. So both the quadratic and the cubic function are continuous. Right? So far we haven't seen a single discontinuous function. So the next function we're going to study is the reciprocal function. And that's the function f of x equals 1 over x. This is the first function that we've seen that was or will be discontinuous. It is not a continuous function. And this was kind of hard to understand sometimes. So here I have x, here I have y. All right, so let's explore this function. Let's plug in some values. Remember not to neglect the negative values when we plug values in. So let's try x to be, let's try negative 1/2. No, let's try negative 2 to begin with. When x is negative 2, f of x is negative 1/2. That's the reciprocal, okay? X is 2, y is negative 1/2. Sorry, negative 2, negative 1/2. When x is negative 1, the reciprocal of negative 1 is 1. So let's try negative 1/2. That fits in here. Negative 1/2 would be negative 2. Getting closer to 0, negative 1/3. Negative 1/3, its reciprocal is negative 3. All right? Negative 1/4 would be negative 4. So you see that as we're getting closer and closer and closer to 0, these numbers get really, really big, okay? So right here, between negative 1 and 0, these values are getting quite large, all right? What happens at 0? Well, what is 1 divided by 0? Remember, that's a no. That's undefined. It's what we call an asymptote. There's an asymptote and we'll talk more about these later. There's an asymptote at the line x equals 0 because we can't plug 0 in for x. So that's this line right here. That's the y-axis, is the line x equals 0. So we can't plug in a value here. We won't get any output either. All right, so what happens? Let's reverse this. Let's try 1/4. Notice 1/4 is 4. 1/3 is 3. 1/2 is 2. So you see now again we're getting, as we were getting closer to 0, it was getting to be a bigger number. And this one, it was getting to be a bigger number, but it was getting more negative. So actually it would be a smaller number. But here, that whole number is increasing. But once I hit 1, it starts decreasing again. Okay, so here as we're getting closer to 0, this value is increasing. But after 1, then what I see is, so for 2 is 1/2, 3 is 1/3, etc. Gets really, really, really small. I'm never, ever, ever going to get 0. There's no number that I could plug in that will ever give me out 0. I'll just get something very, very small. So like 100 would be 1 over 100. That's tiny, but that's still a number. 1 over 1,000, 1 over 1,000,000. It's getting closer and closer and closer to 0, but it's never ever going to be 0. So we're never going to get an output of 0 either. So there's an asymptote also at the x-axis, at the line y equals 0 or f of x equals 0. So let's plot some of these points. At negative 2, I had negative 1/2. That'd be halfway between that, so about there. At negative 1, I had 1. At negative 1/2, I have 2. At negative 1/4, that's like halfway here, I would have 4. So right about here, maybe. 1, 2, oh, that's 3. Let's go to 4. Right. So what we see is a graph that looks something like this. Right. Gets really close to those axes, but never ever touches it. All right. But what about these values here? Need to graph those values too. So I'm going to graph, well, 0 can't happen. At 1/4, I have 1, 2, 3, 4. At 1/4, I have 4. At 1/2, I have 2. At 1, it's 1. At 2, it's 1/2. At 4, it would be 1/4, something like that. So we see that it's increasing here, getting really close to the y-axis, but never touching it. Decreasing here, getting really close to the x-axis and never touching it. Right? That's the reciprocal function. Now, like it, the reciprocal squared function is really similar. The reciprocal squared function it also has those same values in that first quadrant over here. In the first quadrant. So for the reciprocal squared, f of x equals 1 over x squared. That's the reciprocal squared function. So I have these values, right? No, take that back. They're a little bit different because we're squaring it. So the values are a little bit different. So it has the same shape, but let's look at a table of values. So when x is negative 2, f of x is negative 1/4. Right? When x is negative 1, f of x, I'm sorry, I'm squaring it. It's positive 1/4. When x is negative 1, I have a positive 1. When x is negative 1/2, I have a positive 4. When x is negative 1/4, I have a positive 16. Right? And as I get close to 0, 0 is again undefined. Okay? Again, an asymptote. Okay? Then let's say at 1/4, I have 16. At 1/2, I have 4. So because of this undefined, it means that there's an asymptote there. It means that I'm going to have to pick up my pencil. That's why these two are discontinuous. They're discontinuous graphs. So this is my y-axis, this is my x-axis. Let's make this 1, 2. Let's make this 1, 2, negative 1, negative 2, negative 1, negative 2. All right, so there's an asymptote again on the axes. All right, so there's an asymptote here, and there's an asymptote here. We can't plug in 0 for x, and we're never ever going to get out a 0 for y. So let's plot these points. When x was negative 2, y was positive 1/4. I'm sorry, if that's 1/2, then this is 1/4. All right. When x is negative 1, y is positive 1. When x is negative 1/2, I have a positive 4, which is way off the charts. So let's say, let's pop another value in here. Let's say it is 3/4. Nah, I don't want to square 3/4. 16 over 9 is kind of an ugly number to graph. Anyway, so it's way, way off the charts. So anyway, the graph looks like this. Okay. I should say it's a lot steeper than that. At 1/2, it's way up at 4. So it's very, very steep. But again, it's going to approach this axis here and here. Again, 1, 1, and then 1/4 and 16. It's too far off the charts. 1.5. Okay, so at 2, it's 1/2. At 3, it would be 1/9, which is tiny. So at 1/2, it would be 4, which is off the charts again. It's steep. It's going to approach this axis but never touch it. And it's going to approach the x-axis and never touch it. So it's discontinuous. If I put my pencil or pen down here, I could draw this half of the graph without picking it up. But I have to pick it up and move it over here to draw this half because these two parts will never connect because there's an asymptote, like a fence in the middle of the two that it cannot cross. All right, next we have the square root function. Now the square root function, we aren't allowed to put in any negative numbers. So if I try to put in a -1, that's not real. It's not even undefined, it's just not real. All right. The first number I can put in, the first thing that does have a square root is 0. The square root of 0 is 0. Could I take the square root of 1/4, positive 1/4? Yeah, that's 1/2. Could I take the square root of 1? It's 1. The square root of 2 is 1 point something. Okay. The square root of 3 is also 1 point something. The square root of 4 is nice because the square root of 4 is 2. All right, and I can continue on this. The next thing that's nice to take the square root of is 9. The square root of 9 is 3. Okay, so those are some values that are pretty to graph. These ordered pairs, not so much. So I have 0, 0, 1, 1. 1/4 is 1/2, so something like that. And then the next one is 4 is 2, 9, 1, 2, 3. The next time I'd have to see something is I'd have to go all the way out to 16 to see 4, 25 to see 5, etc. All right, so this graph goes like this. Now notice it continues to grow forever, but it grows really, really slowly. Right? The change between here and here is 1, but the change, it takes 4 x values to grow another 1 for the y value. And then it takes 5 to grow another 1. Sorry, it takes 3 here. Then it takes 5 to grow another 1 y value. Okay? And then 7, and just gets bigger and bigger from there. But it always, always grows, right? And you could put anything in here. This one is a continuous function. It's all one graph, it's all connected. I don't have to pick up my pencil ever to draw another part, right? Last but not least, the cube root function. So the cube root function is the function f of x equals the cubed root of x. So let's make a table of values, x f of x. So when I do that, again, start with negative values. There's a reason I've gone all the way out to -8, because -8 has a nice cube root. The cube root of -8 is -2, because -2 cubed is -8.